Hello, we are the Biofuels and this is the Powerhouse.
One of the biggest sources of wasted energy in the US and the UK is energy wasted inside the home. 60% of energy wasted in the US is from lighting devices being left on when they aren't being used. Similarly, the devices being left uncharged when they don't need to be is also a big waste of energy and something that could be easily avoided if people took the initiative. Another big problem is having the heating on when it's not needed and wasting a large amount of both energy and money.
So in our initial brainstorms, we came up with these ideas. We've got a tilting solar panel, a water cleaning solar panel, cooling system solar panel, a vertical wind turbine, insulated roller blinds, closing windows, insulated doors, and only heat and light rooms that are in use.
To keep energy costs at a low for the average Joe, we thought that energy transition in the house would be most suitable for this given topic. So in order to do this, we should keep energy costs in the house at a low minimum.
These roller blinds are a cheaper and easier to install alternative to double glazed windows, and they keep the house cool in the summer because they reduce ventilation because they don't trap heat in. In each room, there are temperature sensors that can communicate with the Raspberry Pi to tell the blinds to close, as that reduces heat loss, which reduces the amount of energy lost.
On top of this model house, we have a solar panel generating energy. Our solar panel is designed to follow the direction of the light. This ensures that the maximum amount of sunlight is being absorbed at any given time. One problem is that particles such as dust can build up on the solar panels, which reduces the amount of sunlight that the solar panels can use to create energy. To counter this, we've built a cleaning system using filtered rainwater, which can be activated manually or set at certain intervals. This should reduce the amount of dust and allow the solar panels to collect energy more efficiently. As you can see here, there are plenty of places where heat can escape, such as through these windows and walls. To rectify this, we're using a model of a door that should automatically close. Unlike most households, schools already have these already built into them. But by creating a more commercially viable version of these for households, they'll be able to save energy wastage. The doors are also padded with an insulating material, which prevents heat loss through conduction. These curtains are a cheaper and easier to install alternative to double glazed windows. They can keep the house cool in the summer, which reduces the need for ventilation, as heat isn't trapped in the house, and it reduces the need for heating in the winter.
As you can see, when the window is open, heat can be dissipated and lost. This can mean that heating costs can increase as your heat is going to the outdoors.
Every 5 minutes, this motion sensor detects if there's any movement in the room. And if there's no movement, it shuts off all the lights and the heating as well.
The relay here controls the lighting and the heating. Here, David is using our web server, which controls the Raspberry Pi. We have made our website so that every time you click a button, it updates on all browsers. We have made the graph dynamic, so it is able to update without having to refresh the browser. This shows you all the energy consumption which you are using in the house. If you switch on the heating or the lights manually, it automatically updates on the website too. This means that the web browser is always 100% accurate to the current time. This is a demonstration of the project working fully. The Raspberry Pi is hosting a web server, which is the one here, and as you can see, it's running on a local host. This means that anyone connected to the same network in the house can access this and control. The ESP is completely wireless from the Raspberry Pi itself, and this setup is for the kitchen. If I click off, it will switch off the light. If I click back on, it will switch on. Now we're going to test the heaters. Folding the roll blinds down would insulate heat, as the roll blinds are made out of felt, which is a good insulator. Say if we turn on the heat from here, the light should light up and the roll blinds begin to roll down. What would you say is efficient about our solar panel in our house?
My professional opinion is that your solar panel is very efficient.
David has some comments to say about our project.
I love it.